All right, in this video, we're going to talk about section 2.4 dealing with the derivative. And in this section, we're going to be finding the average rate of change. We're going to be writing the equation of the tangent line, given the slope of the function at that point. Also, we'll use the four-step process to find the derivative of a function and evaluate the derivative. And then we're going to solve applications that involve derivatives and rates of change. All right, so we're going to begin with the definition of rate of change. All right, so the definition is this: for y equal some function f of x, the average rate of change from x is equal to a x is equal to a plus h is this: f of the quantity a plus h minus f of a, all divided by h, where h is not equal to 0. Okay, now the visual interpretation of that rate of change is here. Okay, now that expression I just talked about is what we call the difference quotient. And it can be interpreted as the slope of the secant line. Okay, so here's a visual interpretation of that. The secant line, by definition, is nothing more than a line that crosses the graph at two different places. Okay, that's what a secant line is. So in this visual interpretation, the graph that I'm going to outline, let's say in purple, which is this line right here. Here's the graph of y equal f of x, by the way. And you'll see that this secant line is crossing the graph at two different points, P and Q. So if I connect those, you're going to see what that secant line is. So here's that secant line right here. And across the graph at these 2 points, P and Q. Now, the ordered pairs for P and Q, I'll indicate those as well. So in case your P is at A, and then you have f of A. A is your x coordinate, f of A is your y coordinate. So the ordered pair for that would be A, comma, f of A. And here's Q up here. For the x coordinate for that would be A plus H, because that's going to be the point H units to the right of A. So that's A plus H. And then here's f of x here for the y coordinate. So Q has the ordered pairs A plus H and f of A plus H. Okay. So if I was to, let's say, use the slope formula to find the slope of the line going through those 2 points, P and Q, and if you recall from college algebra or from another developmental math course, the slope formula would be this: m is equal to y2 minus y1, and the whole thing is divided by x2 minus x1. All right, so the slope is y2 minus y1 divided by x2 minus x1. Here I'm going to let f of a plus h be x2 and y2 and f of a be y1. So this will be f of a plus h minus y1, which is f of a, divided by x2. This is x2 a plus h minus x1. That's going to be a. Now, the numerator is already simplified as f of a plus h minus f of a divided by a minus a plus h, and then minus a minus a, that's gone. That adds to 0. So in this case here, you're left with h in the denominator. So that equation, that difference quotient, represents the slope of the secant line. And sometimes they use this notation, m with the SEC as their subscript, meaning the slope of the secant line. And the secant line is just a line that goes through the graph at two different places. Okay. So in this first example, we're going to do this. Here, we're going to find the indicated quantities for f of x equals to 5x squared. And in part A, they want the slope of the secant line through the points 1 comma f of 1 and 1 plus h comma f of 1 plus h. And here in this case, your h value is not going to be equal to 0. Your h is not going to be equal to 0. So in this case here, let's start with part A. Now the first order pair is 1 f of 1. And here f of x is 5x squared. So let's first find out what that y coordinate is going to be when x is equal to 1. So let me see, off to the side, I'll do this up here. F of 1 is equal to 5 times, here, I'm replacing the x with 1, so it'll be 1 squared. So it'll be 5 times 1 squared, which is 1, and then 1 times 5 would be 5. So the ordered pair here would be 1 comma 5. And then f of 1 plus h. Here we're going to replace the x with the 1 plus h. So this will be 5 times 1 plus h quantity squared. Now that 1 plus h quantity squared, here you have to write this out as a factor twice and then apply the FOIL method. So here I'm going to do this on some scratch paper here. That 1 plus h quantity squared, I had to write that as 1 plus h times 1 plus h, because notice that 1 plus h is used as a factor 2 times. So in this case here, we use the FOIL method by doing 1 times 1, which is 1. The outer 1 times h will be plus h. The inner h times the 1 would be another plus h, plus the last times the last h times h, which is h squared. And then next we're going to combine like terms here. So this will be 1 plus h plus another h will be 2h plus h squared. So 1 plus h quantity squared will be 1 plus 2h plus h squared. So I'm going to have a 5 multiplied by 1 plus 2h plus h squared. And then we use the distributive property. Distribute the 5 over the 1 plus 2h plus h squared, you'll end up with 5 plus 10h plus 5h squared. So for 1 comma f of 1 plus h, that will be 1 comma, and then that expression 5 plus 10h plus 5h squared. And now to find the slope of the secant line, so here I'm going to say MSEC for the slope of the secant line. This will be y2. That's the f of 1 plus h. And I'll write this out, f of 1 plus h minus f of 1 divided by, and this should be 1 plus h, by the way, y2 minus y1, 1 plus h minus 1. So here that second order pair should be 1 plus h for the x coordinate, as you can see here. All right, so now let's simplify this a bit. F of 1 plus h is this right here, that 5 plus 10h plus 5h squared minus f of 1, which is 5. That's divided by, now 1 minus 1 will give you 0, so you'll be left with the h. So here I can Cross out the ones because that adds to 0. And also I can cross out the 5. If you look at the numerator, 5 minus 5, that's 0, so that's gone. So I'm left with just variables in terms of h, or expressions that are in terms of h. So this would be 10h plus 5h squared divided by h. Now the numerator, the only thing we'll factor out is just the h. Okay? Even though 10 and 5 have a common factor of 5, I'm not going to be able to divide the 5 out in the denominator. So, oops, let's just factor out the h. Factor out the h. So that means 10h divided by h will be 10, plus 5h squared divided by h would just be 5h. All that's divided by h. So here the h's divide out. You'll be left with just 10 plus 5h. And that would be the slope of the secant line going through those 2 points, 1 comma f of 1 and 1 plus h comma f of 1 plus h. Okay. So that was part A. Part B is to find the slope of the graph at 1 comma f of 1. So at pretty much at the ordered pair 1 comma 5, this is where we take this expression here, 10 plus 5h, and take what they call the limit as h approaches 0. If you recall back in section 2.1, we did talk about limits and how to take limits here. And one of the concepts that I discussed in that video for section 2.1 is the difference quotient and taking its limit. So in this case, we're going to take the limit as h approaches 0 of this expression, 10 plus 5h. Okay. Now, we have a limit of a sum. We can write this as the sum of their individual limits. So it'll be the limit as h approaches 0 of 10 plus the limit as h approaches 0 of 5h. Well, the limit of a constant is just going to be a constant. So we're going to have 10 plus the limit as h approaches 0 of 5h. Well, 5h is just a linear expression. We can use direct substitution. So just replace the h with 0. That means 5 times 0 is 0. So we're going to end up with 10. And this will be the slope of the line of the graph at the point 1 f of 1. So 10 will be your slope. Part C is the equation of the line, the equation of the tangent line at 1 comma f of 1. And we're going to talk about tangent lines in a few minutes. So in part C, we have the ordered pair, the point, and I'm going to write this point as 1 comma 5 because when we replace the x with the 1, the y coordinate was 5. If you recall, back up here, x was 1, it ended up being 5. F of 1 ended up being 5. All right, and the slope is 10, so it's m, which is 10. And of course, we use the point slope form, which is, of course, y minus y1 is equal to m, the slope, times x minus x1. And then the 1, that will be x1, and the y1 will be 5. So in this case here, we just substitute the y1 with 5, so it'll be y minus 5, equaling the slope, that's 10, times x minus x1, which is 1. And then we distribute the 10 over the x minus 1, we'll bring down y minus 5. The right side of the equation, 10 times x will be 10x, minus 10 times 1 will be 10. And then to solve this equation for y, we're going to add 5 to both sides. So that means we're going to have y is equal to 10x minus 5. Okay. Now, let me advise you, if you're not familiar with point-slope form, if you're not familiar with the slope formula, I would suggest you look at it, one of the college algebra videos. And I think that's section 2.4 dealing with linear functions and slope. I do talk about the slope formula. I do talk about point-slope form. So watch that video if necessary. All right, now let's talk about the definition of instantaneous rate of change. Instantaneous rate of change. Here we're going to consider the function y equal f of x only near the point P with the ordered pair a comma f of a, with the coordinates a comma f of a. The difference quotient, which is f of a plus h minus f of a, all divided by h, where h is not equal to 0, gives us the average rate of change of f over the interval a comma a plus h. Now, if we make h smaller and smaller, in the limit, we obtain the instantaneous rate of change of the function at the point P. So in this case here, the limit as h approaches 0 of f of a plus h minus f of a divided by h. Okay. So here, that last example that I did, this is where I took the limit. So here we were doing the instantaneous rate of change here. All right, so now the next page is a visual interpretation of instantaneous rate of change. All right, so what that means here is this. If you recall that, well, by definition, this is what the tangent line is. By definition, the tangent line is just the line that touches the graph at the single point. The secant line crosses the graph at 2 different points. The tangent line touches the graph at 1 point, just touches the graph at a point on that curve. So this line right here represents a tangent line, as you can see. And we have P and Q. And let's say P is on it, is a point on that curve. All right, so what's going to happen here is this. Pretty much the distance from A plus H to A, that's this H right here. Here we're letting H approach 0. So here at A is this point P, and at A plus H is this point Q. If I take a point that gets closer and closer to where A is, that means H is going to be approaching 0. That means this distance is going to get smaller, but the distance between A plus H and A would get smaller and smaller and smaller. So let's say I pick this point right here. That would mean that this point will fall right here on the curve. So from this point to where P is, this would be, actually, we're just going to be drawing tangent lines. So here's a tangent line right here on that point that I've chosen. And if I pick a point that's closer to that, let's say, if this is the point right here, let's say here's a point right here that I can choose. And here's a point, this point would be here. And if I draw a tangent line, another tangent line at that point is the red line. That's going to be your tangent line. The idea here is this: if I continue to draw more and more tangent lines, if I pick points closer and closer to that these secant lines will end up becoming the tangent line. or get closer and closer to becoming the tangent line, I should say. Okay, so when we let h approach 0, here it's going to get closer and closer to this point P, which will end up being the tangent line. Okay. So here, if you're given y equal f of x, the instantaneous rate of change at x is equal to a is equal to the limit as h approaches 0 of f of the quantity a plus h minus f of a, provided that the limit exists. And this can be interpreted as the slope of the tangent line at the point a, comma, f of a. Okay, so the more tangent lines I draw, then what's going to happen here is I'm going to end up getting the tangent line eventually. All right, so here's an example. All right, it says here for f of x is equal to 1 divided by 1 plus h quantities, 1 plus h squared. The slope of the graph of y equal f of x is known to be negative 4/25 at the point where with the x coordinate of 2. Find the equation of the tangent line at that point. So here's what we already know. We already know that the slope of the graph of y equal f of x is known to be negative 4/25. So we have our slope m, which is negative 4/25. And we have the x coordinate to be 2. That would mean x has to be equal to 2. So we can use this function, f of x. I'll rewrite this. F of x is equal to 1 divided by 1 plus x squared, and find out what that y coordinate is by just replacing our x with 2. So the f of 2 is equal to 1 divided by 1 plus 2 squared. So here we got 1 over 1 plus, well, 2 squared will be 4, and then the denominator, 1 plus 4 will be 5. So I have 1/5 as the y coordinate. So my ordered pair for that point would be 2 1/5. 2 1/5. And I know my slope is going to be negative 4/25. So we can use the point slope form and find out what the equation of the tangent line at this point. So x1 will be 2, y1 will be 5, 1/5. So our point slope form, if you recall, will be y minus y1, and that's equal to m times the quantity x minus x1. So in this case here, y minus y1 would be 1/5. That's equal to the slope m, that's negative 4/25, times the quantity x minus x1 would be 2. And then we just simply distribute and get the y by itself. So it'll be y minus 1/5 is equal to negative 4/25 times x, will be negative 4/25 x minus, well, minus times a minus will be a plus, by the way. 4/25 times 2 over 1 will be 8/25. And then to solve for y, we're going to add 1/5 to both sides of this equation. So that means I'll have y is equal to negative 4/25 x. And then 8/25 plus 1/5 can be done in the calculator. So in this case here, clear this out. All right, negative, and then 4 divided by 25, close parentheses, plus, and then left parentheses, 1 divided by 5. And then from there, I'll hit the math key, then number 1, because it needs to be in a fraction. Oh, I'm sorry. Correction. 8/25. So be left parentheses 8 divided by 25 plus left parentheses 1 divided by 5, close parentheses. And then hit the math key and then number 1 for fraction. It'll be 13/25. Okay. So y equal negative 4/25 x plus 13/25 is the equation of the tangent line at the point 2 1/5. Okay. All right. Now let's talk about the definition of the derivative. Here it is. For y equal f of x, we define the derivative of f at x denoted f prime of x to be f prime of x equaling to the limit as h approaches 0 of f of x plus h minus f of x divided by h, if the limit exists. Now, this notation that you see here, f with a dash here, not the dash. This notation here, that's read as f prime of x. Okay, f prime of x. Now later on in another video, we're going to be talking about notations for the derivative. And this is one of them, f prime of x. And if f prime of a exists, we call f differentiable at a. And if f prime of x exists for each x in the open interval a comma b, then we can say that f is said to be differentiable over the open interval a comma b. The process of finding the derivative of a function is called differentiation. The derivative of a function is obtained by differentiating the function itself. Okay. Now, there are some interpretations of the derivative, and we have 3 of them right here. So if f is a function, then f prime is the new function with the following interpretations. For each x in the domain of f prime of x, f prime is the slope of the line tangent to the graph of f at the point x f of x. So here, some of the couple of examples that we did dealt with the slope of the line tangent to the graph. That's how we use the first derivative. And then second, for each x in the domain f prime of x is the instantaneous rate of change. Instantaneous rate of change of y equal f of x with respect to x. And then if f of x is the position of a moving object at time x, then v, which is going to be the velocity, equaling to f prime of x. That's the velocity of an object at that time. Okay. So there are 3 different interpretations of the derivative here. One would be the slope of the tangent line at that point. Also, instantaneous rate of change with respect to x. Also, the velocity of an object, if the function is a position of a moving object. All right, next is the procedure. And we have a 4-step procedure for finding the derivative of a function f. The first step is to find f of x plus h. Just substitute each x in f of x with the x plus h and simplify. Then step number 2, you're going to subtract f of x from f of x plus h. And then whatever that is, step number 3, you'll find this by dividing whatever you got in step number 2 by h. And then finally, step number 4, you'll take the limit as h approaches 0 of, excuse me, of this function right here, this expression, f of x plus h minus f of x divided by h. So here we're going to apply that 4-step procedure to some of these examples that I have in this video. So here's one of them right here. Here you're going to use the 4-step process to find s prime of x. and then find S prime of 1, S prime of 2, and S prime of 3. So in this case here, we have S of x is equal to 8x minus 3. So here we're going to find S prime of x using that four-step process. So in step number 1, you're going to find f of x plus h. And I don't want to use f of x plus h since we're using s. Let's be consistent, just use s of x plus h. And then just replace each x with that x plus h. So it'll be 8 times the quantity x plus h minus 3. All right, and then simplify that. 8 times x will be 8x plus 8 times h will be 8h minus 3. And that's as far as we can go with that. So that's step number 1. Number 2, we're going to do s plus h minus s of x. So we already know what s of x plus h is. That's the 8x plus 8h minus 3. We're going to subtract from it s of x, which is 8x minus 3. And notice I'm putting 8x minus 3 in parentheses because I'm subtracting the whole thing from s of x plus h. Now, if I simplify this, 8x plus 8h minus 3, the minus sign makes the 8x minus 8x, the minus sign makes the minus 3 a plus 3. And then when I simplify this, notice that the 8x are gone. 8x and minus 8x, that's 0. Minus 3 and plus 3, that's gone. I'm just left with 8h. Okay. So that's step number 2. All right, step number 3 is take that s of x plus h minus s of x, divide that by h. So we're going to take that 8h, divide that by h. And notice that the h's divide out. You're just left with 8. And then step number 4 is to take the limit of as h approaches 0 of s of x plus h minus s of x. I'll divide it by h. Well, that numerator came out to be this, the 8 over, well, the whole thing came out to be 8. I'm sorry. So all we need to do there is just take the limit of that. Limit as h approaches 0 of 8. And the limit of a constant is a constant. So the limit as h approaches 0 of 8 ends up being 8. Okay. So s prime of x ends up being 8. So I guess I can write that out. S prime of x is equal to 8. Now we're going to use that to find s prime of 1, s prime of 2, and s prime of 3. So in this case here, s prime of 1, this is going to be easy because I have no x to substitute for just the 8. So s1, s prime of 1 would just be 8. And then s prime of 2, again, going to be 8. And s prime of 3, it's just going to be 8. Okay. So actually here, that derivative came out to be a straight line. So whatever x value you have here, s prime of that will always be 8 in this case. All right, let's look at the next example. Again, we're going to use the four-step process to find f prime of x, and then find f prime of 1, f prime of 2, and f prime of 3. This time is x squared, f of x equal to x squared plus 7x minus 9. F of x equal to x squared plus 7x minus 9. So in this case here, the first thing we'll do here is find f of x plus h. So here we're going to substitute each x with the x plus h. So the x plus h quantity squared plus 7 times x plus h minus 9. And then we're going to simplify that. That x plus h quantity squared, the x plus h again is used as a factor twice. So we need to write that as x plus h times x plus h. So here x plus h, x times x would be x squared. The outer x times h plus h, xh plus h times x will be xh again plus h times h, h squared. Again, I'm using a for method. So the x squared, bring that down. I got two xh's here, so I'm going to write that as plus 2xh plus h squared. So that's what x plus h quantity squared will be. X squared plus 2xh plus h squared. And then next, I'm going to distribute the 7 over the x plus h. I will get plus 7x plus 7h minus 9. And I don't have any terms to combine in this case. So this is what f of x plus h will be: x squared plus 2xh plus h squared plus 7x plus 7h minus 9. That's step number 1. Step number 2 is to take that f of x plus h and subtract f of x from it. So that means I'll write down that x squared plus 2xh plus h squared plus 7x plus 7h minus 9, and then minus, and in parentheses, what f of x is: x squared plus 7x minus 9. All right, next, bring down the x squared plus 2xh plus h squared plus 7x plus 7h minus 9. The minus makes the x squared minus x squared. The minus sign makes the plus 7x minus 7x. The minus sign makes the minus 9 plus 9. So now we can get rid of the x squares. That adds to 0. We can also get rid of the 7x. 7x minus 7x is 0. Minus 9 and plus 9 is 0. So you're just left with terms, with expressions that are in terms of h. So here you got 2xh plus h squared plus 7x, 7h. Okay. So all of that was step 2. All right, step number 3 is to take that f of x plus h minus f of x, divide the whole thing by h. So here I got that 2xh plus h squared plus 7h. All that's divided by h. Now, in the numerator, I can factor out an h. Okay, let's factor out the h. 2xh divided by h would just be 2x. H squared divided by h will just be h. 7h divided by h would be 7. And then you'll divide that by h. So here the h's divide out. So you'll be left with 2x plus h plus 7. And now finally, step number 4 is to take the limit as h approaches 0 of f of x plus h minus f of x divided by h. So now the limit as h approaches 0 of this expression 2x plus h plus 7. Okay. The limit as h approaches 2x, that's just going to be 2x. As we let h approach 0, this h right here will be going to 0. And then the limit of a constant is a constant. So you're left with 2x plus 7. So this is what f prime of x will be. 2x plus 7. Okay. Now the next step would be to just find f prime of 1, f prime of 2, and f prime of 3. Well, f prime of 1 is where we just substitute the x with the 1, so it'll be 2 times 1 plus 7. Well, 2 times 1 would be 2, 2 plus 7 would be 9. So that's what f prime of 1 will be. F prime of 2 is just replacing the x with 2 again. 2 times 2 plus 7. Well, 2 times 2 will be 4. 4 plus 7 would be 11. And then finally, f prime of 3, that'd be 2 times 3 plus 7. 2 times 3 will be 6. 6 plus 7 is 13. So f prime of 1 would be 9, f prime of 2 would be 11, and f prime of 3 would be 13. Okay. All right. Here's example 5. Now this one has a square root in it. And I want you to be, for me, we're doing using the definition of derivatives to find expressions that have a square root in them. All right, so let's use that 4-step process to find f prime of x, and then find f prime of 4, f prime of 6, and f prime of 8. And here f of x is equal to 14 times the square root of 13. And here's the 4-step process. So step number 1 is to evaluate f of x plus h. So here we just replace that x there with the x plus h. So it'll be 14 times the square root of, that x will be replaced with x plus h, and then plus 3. Now, if you want to, you can write this without the parentheses. So it'll be 14 square root of x plus h plus 3. All right, so that's step number 1. Now, step number 2 is to take the f of x plus h, subtract f of x from it. So f of x plus h was 14 times the square root of x plus h plus 3, minus f of x was 14 square root of x plus 3. Well, these two terms have the common factor of 14, so if I factor out the 14, this is what I have. 14 times, and in parentheses, x plus h plus 3 minus the square root of x plus 3. Okay. So that's step number 2. Step number 3 is this. We take that f of x plus h minus f of x, divide that by h. So here I got the 14 times the quantity of the square root of x plus h plus 3 minus the square root of x plus 3. And divide that by h. Now, where do we go from here? All right, so here's what we need to do right here. You see this expression right here? I'm going to multiply the numerator and the denominator by what they call the conjugate of that expression. Now, the conjugate by definition is this. If I have A plus B, its conjugate would be just the same two terms, but I just changed this from a plus to a minus. And this works the other way around. So if you have like A minus B, its conjugate would be A plus B. So this is what I'm going to do in this problem. I'm going to multiply the numerator and the denominator by the conjugate of this right here. Because what I want to do here is get a sum and a difference of two terms. Okay. So here's what I'm going to do. I'm going to multiply the numerator and the denominator by its conjugate. The conjugate will be the square root of x plus h plus 3. This minus will change to a plus, the square root of x plus 3. Now I do the same thing in the denominator. Square root of x plus h plus 3 plus the square root of x plus 3. I'm going to put these in parentheses, by the way. Now, the reason why I'm doing that, because I'm going to have what they call the sum and the difference of the same two terms. There is a rule when you multiply the sum and the difference of the same two terms. So I have something like A plus B times A minus B. The quick way of doing that would be to take the square of the first term, that's A squared, minus the square of the second term, that's B squared. That's exactly what I'm going to do here. So in this case here, I'll bring this 14 down. And then I'm going to square the first term. And I'm going to write this out like this. X plus, now square root of. Let's start with that first. Square root of x plus h plus 3. That's going to be squared minus the square of the second term, the square root of x plus 3. That's going to be squared. That whole thing is divided by h times the square root of x plus h plus 3 plus the square root of x plus 3. I'm going to bring down the 14. Now this right here, when I take the square root of something and I square it, it wipes out the radical. So the square root of x plus h plus 3 and that squared, that radical is gone. You're left with just x plus h plus 3. Minus, same thing here, the square root of x plus 3, and I turn around and square it, it's going to wipe that radical out. You're left with just x plus 3 in the numerator. Let me put my other parentheses here. All that's divided by h times the square root of x plus h plus 3 plus the square root of x plus 3. Now I'm still going to simplify that numerator just a bit. So here we got 14. And then in parentheses, x plus h plus 3. The minus sign makes the x minus x. The minus sign makes the plus 3 a minus 3. Then I'll rewrite my denominator. All right. So now you're going to see your x's are gone. That gives 0, and 3 is gone. You're just left with an h in the numerator. So I will have in the numerator 14 times h. Oh, that's going to be divided by h times, and in parentheses, the square root of x plus h plus 3 plus the square root of x plus 3. And as you can see here, your h's are going to divide out like this. So that means I'm going to end up with a 14 in the numerator divided by just the square root of h plus 3 plus the square root of x plus 3. So all that's in the denominator. So that's what f of x plus h minus f of x divided by h will end up being after you simplify all of this. And then finally, step number 4 is to take the limit as h approaches 0. Of f of x plus h minus f of x divided by h. So the limit as h approaches 0 of this expression, 14 over the square root of x plus h plus 3 plus the square root of x plus 3. Now, bring the 14 over. As we let h approach 0, x plus h plus 3, this h right here will go to 0. So that means I'll have the square root of x plus 3 plus another square root of x plus 3. Notice I got 2 of them, so I can write this as 14 divided by, I have 2 square roots of x plus 3. I'll just write it like 2 square root of x plus 3. And guess what? I can divide 2 into 14. That will go 7 times. So that means here, I will end up with 7 divided by the square root of x plus 3. And that's what f prime of x will be. So here, f prime of x equals 7 over the square root of x plus 3. And now let's find f prime of 4, f prime of 6, and f prime of 8. All right, starting with f prime of 4. This will be 7 divided by the square root of x will be 4 plus 3. So I have 7 over the square root of 7. And they may ask you to simplify this a bit by rationalizing the denominator. So we would multiply the numerator and the denominator by the square root of 7 because they don't want radicals in the denominator. So 7 times the square root of 7 would just simply be 7 square roots of 7. 7 times square root of 7 times the square root of 7, you're wiping out the radical, you're going to end up with 7. And then in this case here, these 7s divide out. All you'll be left with is the square root of 7. So that's what f prime of 4 is. All right, f prime of 6. We substitute the x with 6, so it'll be 7 over the square root of 6 plus 3. So it'll be 7 over 6 plus 3 is 9, so you have 7 over the square root of 9. Now we can take the square root of 9, that would give us 3. So f prime of 6 will be 7/3. Let's see. And finally, f prime of 8. So this will be 7 over the square root of x will be 8 plus 3. So it'll be 7 over the square root of 11. And we'll multiply the numerator and the denominator by the square root of 11. So it'll be 7 square roots of 11 over the square root of 11 times itself will be 11. Now, I'm not sure how far they want you to go. If they want you to rationalize the denominator or leave this radical in the denominator. So whenever possible. So do follow the instructions there. Okay. All right, now let's look at example 6. This one has a variable in the denominator. And we're going to apply the 4-step process to find f prime of x, and then find f prime of 1, f prime of 2, and f prime of 3. So in this case here, we got f of x is equal to 3 plus 4 divided by x. All right, so starting with step number 1, you're going to evaluate f of x plus h. So we just substitute the x with x plus h. So it'll be 3 plus 4 over x plus h. So there's not much we can do there. So that would be what f of x plus h is. Step number 2, f of x minus h, and then minus f of x. So in this case here, we take that f of x plus h, which is 4 over x plus h. Then we subtract from it, 3 over 4 plus x, 3 plus 4 over x plus h. Can't leave the 3 out. 3 plus 4 over x plus h minus, and in parentheses, 3 plus 4 over x. Now let's see if we can simplify this a bit. Bring that 3 plus 4 over x plus h, and then minus the 3, and then the minus 4 over x, distributing the negative over the 3 plus 4 over x. So here the 3's are gone. So you'll have 4 over 4 plus h minus 4 over x. 4 over x plus h minus 4 over x. And then step number 3 is to take f of x plus f of x minus h minus, f of x plus h minus f of x. You're going to divide that by h. So that f of x plus h minus f of x was this, 4 over x plus h minus 4 over x. Oh, that's going to be divided by h. Now, here's what I'm going to do here. Since I'm dealing with fractions here, I'm going to take the LCD of this fraction, and that h. And h is understood to be h over 1. So I'll just say this, the LCD would be this, just the x plus h and then the x. So I'm going to write this as x times x plus h, because those are the only terms that are in the denominator. You got x plus h in the denominator and an x in the denominator. So I'm just going to write it like this. And then what I'm going to do here is multiply the numerator and the denominator by that LCD. So this x will be multiplied by x plus h in the numerator. The denominator, the h, will be multiplied by x. I don't need the h here because I got that here. The denominator will be multiplied by x times x plus h. Now, here's what I'm going to do. Take this up here and distribute over these two terms here. So this 4 over x plus h will be multiplied by x times x plus h minus 4 over x. That would be multiplied by x times x plus h. Oh, that's going to be over h times x times the quantity x plus h. Now, watch what happens here. For this first term here, the x plus h's are gone. That's simplified as just 4x minus For this, these x's are gone. I will have 4 times the quantity x plus h. All that's divided by h times x plus h. Now let's simplify the numerator. Bring down the 4x. The minus 4 times x will be minus 4x. Minus 4 times h will be minus 4h. All that's over h times x times the quantity x plus h. Now notice that your 4x's are gone. So I have negative 4h in the numerator times h times x plus h. Okay. And really, I will need these parentheses here around that x. Now here, these h's divide out. So I'll end up with a negative 4 divided by x times x plus h. And that would be what step 3 will end up being. Then step number 4 is to take the limit as h approaches 0 of that expression. So let's see, number 4 would be the limit as h approaches 0 of f of x plus h minus f of x divided by h. So here the limit as h approaches 0 of, in this case, negative 4 over x times x plus h. Now when I take the limit, well, the limit of a constant is a constant, so it'll be negative 4. This will be x. When I take the limit as h approaches 0, this h is going to go to 0. And then I got the x, so it'll be x times x, which will end up being negative 4 over x squared. So that's what f prime of x will be in this case. So f prime of x ends up being negative 4 over x squared. Now we can find f prime of 1, f prime of 2, and f prime of 3. So f prime of 1 would be this negative 4 over 1 squared. And then negative 4 divided by 1 squared will be 1. Negative 4 divided by 1 would be negative 4. And then for f prime of 2, substitute the x with 2, so it'll be negative 4 times 2 squared. So it'll be negative 4 times 2 squared will be 4. Negative 4 divided by 4 will be negative 1. And then f prime of 3, let me pull the paper up so y'all can see it. F prime of 3 would be this negative 4 over 3 squared. So I have a negative 4 over 3 squared, which will be 9. So it'll be negative 4/9 as the final answer for f prime of 3. Okay. So that's how we use that 4-step process to find the derivative of a function. Okay, now let's look at some applications that are related to derivatives. In this case, suppose an object moves along the y-axis so that its location is y is equal to f of x is equal to x squared plus x at time t, y is in meters and x is in seconds. Find the following: the average velocity or the average rate of change of y with respect to x for x changing from 2 to 5. And then find the average velocity for x changing from 2 to 2 plus h. And then the instantaneous velocity at x equals 2 seconds. Okay, so in other words, when you find the average velocity, the instantaneous velocity, you're going to be dealing with the limit. Okay, so in this case here, let's go, we're going from 2 to 5, in this case in part A. So let's find out what f of 2 is. I'm going to write the equation f of x is equal to x squared plus x. So let's find out what f of 2 is, and f of 5. At x equals 2, we got 2 squared plus 2. We square the 2, you're going to get 4. 4 plus 2 is 6. And then for f of 5, just replace the x with 5, so it'll be 5 squared plus 5. 5 times 5 is 25, plus 5 would be 30. Now, if we want to write this as ordered pairs here, we can do that. One would be 2, 6, the other one would be 5 and 30. So here we want to find the average velocity. That means we're going to have to use the slope formula. Okay, so let me rewrite this as the v, average velocity, which is the slope. And that's going to be, of course, f of 5 minus f of 2, because we're going from 2 to 5. And then divided by our x values, 5 minus 2. So f of 5 was 30, minus f of 2, which was 6. 5 minus 2 will be 3. 30 minus 26 will be 24. 24 divided by 3 ends up being 8. So in this case here, the average velocity or the average rate of change of y with respect to x from x changing from 2 to 5 would be 8. All right, now part B, we're going to find the average velocity for x changing from 2 to 2b. I mean from 2 to 2 plus h. Wow. Well, I already know what f of 2 is. That was what, 6 from part A. And now for f of 2 plus h, 2 plus h. And our f of x function was the x squared plus h. I mean x squared plus x. We just substitute each x with the 2 plus h. So this will be 2 plus h quantity squared, plus the x will be 2 plus h. So now let's use the FOIL method by multiplying 2 plus h times 2 plus h, because that's what 2 plus h quantity squared is. 2 plus h times 2 plus h. So 2 times 2, that will be 4. 2 times the h will be plus 2h. Inside h times 2 will be plus 2h. And then plus h times h squared. So I have 4 plus 2h plus another 2h will be 4h plus h squared. That's what 2 plus h quantity squared will be. Sorry. This will be 4 plus 4h plus h squared plus 2 plus h. I think I can combine some like terms here. 4 plus 2 will be 6. 4h plus another h will be plus 5h plus h squared. So our average velocity would be this. It's going to be f of 2 plus h minus f of 2 divided by 2 plus h minus 2. That's x2 minus x1. All right, f of x f of 2 plus h was 6 plus 5 h plus h squared minus f of 2, which was 6, divided by 2 minus 2 gives you 0, so you'll be left with h. And also, we can zero out the 6. 6 minus 6, that's 0. So you're left with 5 plus h, 5h plus h squared, divided by h. And if I factor out the h in the numerator, I'll be left with 5 plus h divided by h. Your h's divide out, you're left with just 5 plus h. Okay. Now, part C, they want the instantaneous velocity at x is equal to 2. So that means we take the limit as h approaches 0 of this expression, 5 plus h. Well, that's simple. As h approaches 0, this h is going to be going to 0. So 0 plus 5, or 5 plus 0, ends up being 5. So that means that the instantaneous velocity at x equals 2 seconds would be 5. And it'll be 5 meters per second in this case. All right, here's the next example. An object moves along a line so that it is at y is equal to f of x equaling to 9x squared minus 8x at time x in seconds. Find the instantaneous velocity, or v equal to f of x, and find the velocity at times x equals 1, 3, and 5 seconds. And here y is going to be measured in feet. All right, so in this case, here we're finding the instantaneous velocity, which is going to be v is equal to f prime of x. So here we got to use that 8-step procedure to find out what this is, what's going on here. Number 1 is to come up with f of x plus h. So in this case here, this is our function y equals, and I'll write this out, y equal f of x, which is equal to 9x squared minus 8x. So every x we substituted with 9, x plus h. So it'd be 9 times, and in parentheses, x plus h quantity squared minus 8 times x plus h. So I have 9 times. Now somewhere I've already did x plus h quantity squared. Here it is. That's this x squared plus 2xh plus h squared. So I'm not going to go through all that again. So I'll just write the x plus h quantity squared as x squared plus 2xh plus h squared. And then minus 8 times x will be minus 8x. And then minus 8 times the h will be minus 8h. Then I'm going to distribute the 9 over the x squared minus 2xh plus h squared. So this will be 9x squared plus 18xh plus 9h squared. And then bring down minus 8x minus 8h. There are no like terms I can combine, so I'll just leave it like that. So that's step number 1. Now, step number 2 is just subtracting f of x from it. So I have f of x plus h minus f of x. So the f of x plus h was that 9x squared plus 18xh plus 9h squared minus 8x minus 8h, and then minus the 9x squared minus 8x in parentheses. I'm going to bring all of this down because I'm going to distribute the negative over the 9x squared minus 8x. So that minus sign makes the 9x squared minus 9x squared. The minus sign makes the minus 8x plus 8x. And then get rid of the 9x squared and the 8x. I'll be left with just the terms that only have an h in them. So in this case here, we have 18xh plus 9h squared minus 8h. All right, that's step number 2. Step number 3, divide by h. You'll take this expression, divide by h. So that f of x plus h minus f of x was the 18xh plus 9h squared minus 8h. All that's divided by h. If we factor out the h, you'll have just 18x plus 9h minus 8. All that's divided by h. These h's divide out. You'll be left with 18x plus 9h minus 8. So that was step number 4. Step number 3. Here's step number 4. You have to take the limit as h approaches 0 of f of x plus h minus f of x. All that's divided by h. So we have 18x. Well, you have to put the limit symbol first, the limit notation. You can't leave that off. So it'd be the limit as h approaches 0 of 18x plus 9h minus 8. Now, as your h approaches 0, your 9h is the one that's going to be going to 0. So you're going to be left with just 18x minus 8. Okay. So this is what f prime of x will be, or the velocity, which is f prime of x. So your velocity is just going to be 18x minus 8. That's your velocity function. All right, and then they want the velocity at times x is equal to 1, x equals 2, x equals 3, and x equals 5. So at x is equal to 1, your velocity, which is f prime of 1, would just simply be 18 times x, which is 1, minus 8. So 18 times 1, which is 18, 18 minus 8 is 10. So your velocity there at time equal 1 will be 10 feet per second. And then at x equals 3, again, the velocity will be f prime of 3. Just substitute your x with 3, so it'll be 18 times 3 minus 8. 18 times 3 will be 54. 54 minus 8 would be 46. And then at x is equal to, 5? The velocity will be f prime of 5, which will be 18 times 5 minus 8. 18 times 5 will be 90. 90 minus 8 would be 82. So this will be 82 feet per second for the velocity. Okay, so that's how we use that four-step procedure to come up with our f prime of x, which is 18x minus 8. And at x equals 1, your velocity will be 10 feet per second. At x equals 3, it'll be 46 feet per second for the velocity. And at x equals 5, your velocity will be 82 feet per second. Okay. Let's look at an object dropped from a tower 14 feet above the ground. The object's height above the ground, x seconds after the fall, is s of x is equal to 144 minus 16x squared. About how long does it take the object to hit the ground? And what is the object's velocity at the moment of impact? Okay. Let's answer the first part about how long does it take the object to hit the ground. And x, of course, is our time in seconds. Okay. So when it hits the ground, that means that distance is going to end up being 0, because once it hits the ground, that is going to hit 0. Okay, because the object height above the ground is this formula right here. So when it hits the ground, it's going to be 0. So I'm going to let s of x be equal to 0. So here, s of s, which is in this case 144 minus 16x squared. I'm going to let that equal 0. And here's what I'm going to do here. I'm going to move the 16x squared to the other side. So it'll be 144 equaling the 16x squared. So basically, I'm just adding 16x squared to both sides. So when I divide both sides by 16 to get x squared by itself, that means x squared is equal to 9. And to solve for x, I'm squaring it, so I need to take the square root on both sides. Now, since I'm dealing with time, which is going to be x in seconds, x is the number of seconds, time can't be negative. So you have to so square root of x squared would be x, so the square root of 9 would be 3. And we don't use a plus or minus symbol because time is not going to be negative in this case. So in this case, about how long will it take the object to hit the ground? It would be 3 seconds. Since that's what we're finding. Now, the other part is, what is the object's velocity at the moment of impact? So here we got to go through that 4-step procedure to find out what that velocity function is going to be. All right, so let's do this. Now, just draw a line here to separate this from what I'm about to do here. S of x plus h will be step number 1. So we just substitute our x with x plus h. So it'll be 144 minus 16 times the quantity x plus h. All right, so I'm going to bring down the 144 minus 16 times that x plus h quantity squared. I'll bring that back up. You'll see it ends up being this, x plus 2xh plus h squared, x plus 2xh plus h squared. So distribute the negative 16, you got 144. Now distribute that, negative 16 times x squared will be negative 16x squared. Negative 16 times the plus 2xh will be minus 32xh. And then negative 16 times the x squared will be minus 16 h squared. Okay, so that's x plus h will be. Step number 2, subtract your s of x plus h minus s of x. So s of x plus h was that 144 minus 16x squared minus 32xh minus 16h squared minus s of x was that 144 minus 16x squared. And that's going to be in parentheses. Now, we'll simplify this, bring all this down. 144 minus 16x squared minus 32xh minus 16h squared. The minus sign makes the 144 minus 144. The minus sign makes the minus 16x squared plus 16x squared. So in this case here, 144 minus 144, that's gone. Minus 16x squared, the plus 16x squared, that's gone. You're just left with terms that only have the h in them. So I'll have negative 32 8xh minus 16h squared. So that right there is step number 2. And then step number 3, we're going to subtract. No, divide by h. We'll take this and divide that by h. So here we got that negative 32xh minus 16h squared divided by h. And if we factor out the h in the numerator, you'll be left with a negative 32x minus 16h. That's divided by h. Here your h's divide out. And you're left with a negative 32x minus 16h. Final step would be to take the limit of this. So step number 4 is the limit as h approaches 0 of s of x plus h minus s of x divided by h. So here I got the limit as h approaches 0 of negative 32x minus 16h. Well, as h approaches 0, you can see that your minus 16h is going to be going to 0. So you'll be left with just negative 32x. And this is the velocity, the object of the velocities of the velocity. So v, your velocity function, which is actually s prime of x, that's going to be equal to negative 32x. So now, the object's velocity at the moment of impact. So the time that it took for the object to hit the ground was 3 seconds. So to find that velocity, we just go ahead and just substitute the x with 3 in this case. So it'll be negative 32 times x, which is 3. That'll give us negative 96. And that velocity will be in feet per second, since we're dealing with feet in this problem and also seconds. All right. So to answer the question, the object's velocity at the moment of impact would be negative 96 feet per second. Okay. And got a couple of more examples here, and then I'll be through with this video. The revenue in dollars from the sale of X car seats for infants is given by the following function. R of X is equal to 64X minus 0.020x squared. And that's for x is between 0 and 3,200. And the question here is to find the average change in revenue if production is changed from 1,000 car seats to 1,500 car seats. 1,050 car seats. And then use the four-step process to find R of X, and then find the revenue of the instantaneous rate of change of revenue at a production level of 1,000 car seats, and interpret the results. Okay. And by the way, why don't I just do this for the sake of time? I'll just do the last example. I'm going to omit this one. And this will be omitted in the homework as well. So don't worry about that problem. Okay. Here's the last example. The ozone level in parts per billion on a summer day in a certain metropolitan area is given by P of T equaling to 120 plus 14T minus T squared. And in that problem, I would like to use a four-step process to find P of T, P prime of T, and then find P of 5 and P prime of 5. Okay, I'll go ahead and do this one. Then that will end this video right here. So step number 1 is find P of T plus H. So in this case here, just substitute in this formula. P is equal to, P of T is equal to 120 plus 14T minus T squared. All right, so here I got 120 plus 14 times, the T will be replaced with T plus H, minus, here this will be replaced with T plus H, quantity squared. If I simplify this will be 120 plus 14 times T will be 14T, plus 14 times H will be 14H, and then minus. Now that T plus H, that's just like X plus H. It will simplify as T squared plus 2TH plus H squared. So here I got 120 plus 14T plus 14H. The minus sign will make the T squared a minus T squared. Minus sign makes a plus 2TH minus 2TH. And then the minus will make the plus H squared minus H squared. Okay, unfortunately, there are no terms to combine. So this will be P of T plus H. Step number 2, subtract P of T from P of T plus H. So I got the 120 plus 14T plus 14H minus T squared minus 2TH plus minus H squared, then minus that P of T, which was 120 plus 14T minus T squared. Notice I'm putting that in parentheses. So in this case here, this will be 120 plus 14T plus 14H minus T squared minus 2TH minus H squared. The minus makes the 120 minus 120. The minus makes the 14T minus 14T. And the minus makes the T squared minus T squared a plus T squared. I'm going to need that because minus T squared and plus T squared is gone. 14T and minus 14T are gone. 120 and minus 120 they're gone. I should be left with nothing but terms that have an H in them. So this will be 14H minus 2TH minus H squared. Then step number 3 is to take that expression and divide by H. So it'll be P of T plus H minus P of T divided by H. So I got 14T minus 2TH minus H squared divided by H. So if I factor, wait a minute, something ain't right, 14H. Sorry. Because I want all these H's to be gone. So this 14H, this should be 14H here. Okay. So if I factor out the H, I will have 14 minus 2T minus H, all divided by H. And these H's divide out. So I'm left with just 14 minus 2T plus minus H. And then finally take the limit as H approaches 0 of P of T plus H minus P of T divided by H. So in this case here, that limit as H approaches 0 of this 14 plus 2T minus H. Now this H will go to 0 as H approaches 0. So you're going to be left with just 14 minus 2T. So P prime of T is going to be 14 minus 2T. All right. So what I did here was just part A. Part B is to find P of 5 and P prime of 5. All right, so part B, my P of T was 120 minus 14T minus T squared. That's the original function. So P of 5, we just substitute our T with 5. So it'll be 120 minus 14 times 5 minus 5 squared. So this would be 120 minus 14 times 5, that's 70, minus 5 squared will be 25. So 120 minus 70 minus 25 ends up being 25. So pretty much to answer that question there, the ozone level in parts per billion on a summer day after 5 hours would be 25 parts per billion. Now for the P prime of T, that's the average change in the ozone, that came out to be 14 minus 2T. So P prime of 5 would be 14 minus 2 times 5. So 14 minus 2 times 5, which is 10, gives us, what, 4? Yeah. So the average change in the ozone level after 5 hours would be 4 parts per billion per hour. Okay. And I realize that this is a lengthy section on the derivative, so, you know, try to get as much of this as you can, so that way you'll be able to complete the homework problems in section 2.4. And that does complete this video on section 2.4 dealing with the derivative. So Feel free to reach out to me if you have any questions about any of the problems that were presented in the homework in this video and the homework in my MATLAB.